The next case of permutations. So we've got n objects, but some of them are the same. So to look at, they're identical. How do we handle it? Let's build up the idea. Let's take it to the simplest case as possible. We've only got two objects. Now, if they're different, then obviously there's two ways I can arrange them, 2 factorial, so AB and BA. But what if they were the same? How many ways could I arrange them? Well, clearly there's only one. I mean, if they're the same, to look at AA, if I was to swap the A's around, it still would look like the same thing. So we're just talking about to look at it, would it be the same? All right, well, let's try 3 objects. We know if they're all different, we'd have 6, which is 3 factorial. Well, what about if 2 of these are the same? So if 2 are the same, so let's make it 2 A's and a B, we end up with 3 possibilities. So the question is, when it was 2 objects, we went from 2 to 1. When it was 3 objects, we went from 6 to 3. What is the common pattern? So how do you get from 2 to 1 in the same way that you get from 6 to 3? Halve it, is that what I heard you say?
Yeah.
Okay, that's a logical thing, isn't it? So we halved it, or divided it by 2 is another way of saying halve it. All right. Well, and if 3 are the same, then clearly we've only got 1. All right, well, let's push it up to 4 objects. Let's see if that pattern still works. If they're all different, wow. There's 24 different ways of writing out the 4 letters. So if you're right, if the pattern's right, we're expecting 12. We would halve it. Yes, indeed. We get 12. Looks like we're onto something here. So what about if 3 are the same? So let's go back to 3 objects. We've ended up going from 6 to 1. Did we just divide by 6? Because, let's see. If it's just divide by 6, well then I'm expecting 4, aren't I? Yeah, sure enough, it's 4. But what I say to you is it's not that we're dividing by 6, and it's not that we divided by 2. Well, there's 4 the same, just to complete the set. What we're actually dividing by is x factorial. So when you said divide by 2 or halve, you're right, but we're actually dividing by 2 factorial, which is 2. And when the other one was divide by 6, that was right, but we're actually dividing by 3 factorial. What we're doing is we're dividing by the number of ways those objects could be arranged. Because they're the same, I don't have to arrange them. So I divide out those arrangements. So whenever we have some the same, we divide by however many there are of them, factorial. Okay, so top of the fraction, that's the way of arranging n objects, so n factorial. Bottom of the fraction, the number of ways of arranging those objects that are the same, if they were different. So now we can have some fun. How many different words, and remember as far as we're concerned, nonsense words are words, using all the letters in the word Knorton. Knorton. Actually a surname of a student I taught many years ago, but it's great. Look, you've got some N's in there, you've got some O's. So how many letters have we got all up there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if they were all different, it'd be 11 factorial. So we have got 3 n's, so we divide by 3 factorial, and we've got 2 o's, so we divide by 2 factorial. All the other letters just appear once. There we go. We end up with a lot of different words. Your challenge now is to find them. Whew, imagine how long that would take. All right, let's look at an HSC one. And now, in the HSC, they assume nothing. So they tell you the letters A, E, I, O, and U are vowels. How many possible arrangements have we got? Algebraic. 9 letters, so 9 factorial. 2 A's, so we'll divide by 2 factorial. Now let's put some restrictions on it. How many arrangements are possible if the vowels must go in the 2nd, the 3rd, the 5th, and the 8th positions? So all right, we've got to arrange the vowels first. So 1, 2, 3, 4, and I'm hoping we only have 4 vowels in this particular word. Have we? Well, we got A, E, another A, and yeah, oh good. So there's no trick about I'm only going to use so many vowels. So we just need to arrange the vowels only. Well, arranging the vowels only, 4 vowels, but we have 2 A's, so we'll divide by 2 factorial. And once we've worked out the order they're going to go in, we'll just slot them into the 2nd, the 3rd, the 5th and the 8th position. Now we're going to arrange the rest of the letters. And there's just 5 more letters. And they're all different. So 5 times 5 factorial for all the consonants. Yeah, that's a fancy word there for something that's not a vowel. Okay, so 1,440. Just a little bit of theory today. We'll add those to our questions and we can spend the rest of the day.